Thanks for coming, listening to what I'm going to say. I'm going to talk today about speech intelligibility, a little bit about measuring speech intelligibility. But before I start that, I will say that my name is Torben Poulsen. I have been working at the Technical University of Denmark for many years, more than 40 years, within teaching and research, within these areas here, where speech is one of the things, speech intelligibility too. I have also been involved in standardization, but that's not that important in this connection. I'm going to say something about the principle of speech intelligibility measurements. I'm going to say something about the speech material that you can use for these things, and a little bit about the methods, and some examples of all those things, and some final remarks at the end. Here you have a picture of the measurement system that we can think about when we are doing speech intelligibility measurements. We have a transmission system where we would like to know how well such a system can transmit speech in an understandable way. That system here could be a room, like this one, for example. How easy is it to understand what I'm saying at the end of the room, at the back of the room? It could be a hearing aid, for example. How well can that hearing aid transmit the speech so that it becomes understandable? And in order to do such measurements, we will have a speaker that say some words or sentences or whatever it may be, some speech at least. Maybe it's read from some text. It probably will be read from some text. And then it goes through the transmission system into the listener. And that listener will then say or repeat the words that are presented, or writing down what the listener perceives, putting down some text. And there will be an experimenter, typically a person. And in the clinic, it's very often so that the experimenter is just listening to what that listener is saying, and saying okay or wrong, and so on, rating all these things. And there may also be some monitor here that the experimenter can listen to, so that there is a control of everything in this text, And the result of all this is percentage intelligibility. And it's defined as the ratio between the text out, or what's coming out of the listener, and what is put into the transmission system. So you could say the ratio between text out and text in. That's simple enough, and it's done daily around the world in all clinics where you are using speech intelligibility measurements in order to test hearing. But there are so many parameters that goes into all this. For example, which speech elements are you using for the test? Is it single words, or sentences, for example, or some numbers, or maybe some nonsense words? It's all things that you have to decide which system would you use. Then there's the speaker up here. How does the speaker pronounce the words that are said, or the sentences? How fast is that speaker speaking? And the vocal effort. Is it whispering or is it shouting? There's a lot of things coming in here, and all that will influence the way the listener can understand these things. There's also the listener himself or herself, the hearing sensitivity. Is there hearing loss or no hearing loss? How trained is the person in doing such things? Many of the methods are very much involved or influenced by training. And the vocabulary, it's of course necessary that the listener has the same vocabulary as the speaker, or at least the text in. It's very difficult to make speech intelligibility measurements if the listener don't understand the words that are presented to the listener. And then there, of course, the transmission system. That was where we started, actually. How is it with distortion, for example, reverberation in a room, for example, background noise and things like that. So there are so many things going into doing such measurements. And the main problem in this situation or in this connection is that we often have speech in noise, and the problem is to understand speech in noise. In situations like this where there's no noise, it's probably no problem even with a hearing loss to understand what I'm saying. But if there are so many people around here talking together and not with the person that are listening, then you will have some problems. That's a common situation in hearing loss problems, that speech and noise is a problem. And one of the curves that comes out of such a measurement could be like this, that when you increase the level of the speech, then the percentage of understanding, the percentage of words that are understood correctly will increase too. Now the axis here is signal to noise ratio down here, and this is for normal hearing persons. And it may be worth to think about that when the signal to noise ratio is 0 dB, and that means that the speech and the noise has the same level, just as much speech as there's noise, then for normal hearing persons, they will understand almost everything. This is a word test, but they will understand almost everything. Every word would be understood for a normal hearing person in that fairly difficult situation where noise and speech is or are at the same level. So, a little about speech material and the methods. We could have word lists, and in the clinic it's typically either words with only one syllable or with two syllables. That's the main things. You could also have some nonsense words, some meaningless words that are made from consonants, vowels, and consonants. Some constructions there. You know, you have all the letters in the alphabet, and you can make combinations of these with consonant, vowels, and consonants. All these combinations, and some of them are real words in the language, but others may be nonsense words where you just have these funny words that are not part of the real language. You could also have some double consonants, SK something, for example, and double consonants at the end too. That's the nonsense word. You could also have some tests where you use words that are like this: ship, dish, pig, fish. The vowel is the same in all of these. SH here, SH there, SH there. And you can manipulate with these, and by presenting one of these words to the test person and get a response from the test person, you will be able to find out where are the problems in speech understanding for that specific person. Dog, cot, doll, sock, for example. You can make similar words with these changes of just one of the speech sounds in the word. You could have sentences from real life, pure sentences. The days are always warm. That's a statement, that's a word. a sentence, and you could present that to persons, and you could have many different sentences. You could also make some artificial sentences, maybe sentences that are not grammatically correct, but just combinations of words. They will often be meaningless and unrealistic, such sentences, but they may be well suited for testing the ability to hear the words in the sentence. There are also some other artificial sentences that I'm coming back to in a moment with some fixed structure, combinations of words where you have constructed such a sentence, and many more. There are other possibilities. This is just some examples of this. The speech intelligibility parameters that you can play around with, so to speak. You can present signals in a sound field. You can also present it with headphones. That's what is often done in the clinic. You will have to decide something about the presentation level. Is it at a low level, a high level, or maybe the most comfortable level, or whatever? There's many possibilities there. It will also be a matter of deciding whether you are testing with or without the background noise. Often you will use background noise in the clinic so that you're talking about a signal to noise ratio. You also have to decide whether you keep this speech when you're using background noise, whether you are keeping the speech at a certain level and then vary the background noise, or you keep the noise at a certain level and then vary the speech. And you can decide or you can discuss whether one or the other is the best way to do it. That depends on the purpose of that measurement. Then there's the response method. How does the listener respond? Does he or she just repeat what they have heard? Or do they do some writing? Or do they do some pointing on a screen, on a computer screen, for example? And then the scoring method. How do you score how many percentage that are correct? Is it just on words, on sentences, or phonemes, the sounds in the words, or what is it? So there are many parameters coming into all this. I will give you a few examples here. Word list, for example, an open test. That means that you present things like this, true, and then the listener has to repeat, for example, saying true, or whatever that person now understand or perceive, skin, owl, and so on. All these presentations with some pauses in between so that there's time enough for the test person to respond to that. There are many of these lists around in the world, and they are very common. And this result that you saw before is from such a test like this. It's actually from the DanTale, the lists that we are using in Denmark, 25 words in a list. And when you do this for normal hearing persons, then you get this result. The scoring here is for word scoring. Percent correct understood words. But you could go a little bit further down into the details of this and say it could be the percent correct understood phonemes. For example, hat is the word that is presented, but the person responds with cat. And then you will say, okay, it's not totally correct, but there's both the vowel and the final consonant are okay. So let's make use of this information instead of just saying, okay, that word was wrong. So you can also calculate a phoneme score. And the curve here would be similar to this. It will be a little bit further down actually in order to, when we take these phonemes into account. It's not that easy in the clinic to do these things. You need some training as the audiologist to do that in order to listen to what the listener is saying and then calculate how many phonemes that were correct or not. Okay. When we do such measurements with such lists in audiology in the clinic, you could say, let's take a list with 25 words. And we have made one measurement, and then we do the measurements once more. For example, we have changed the setting of a hearing aid or something in between. So we will take an example here with test number 1 gave us 60% intelligibility. That's the point there. We have from 0 up to 100% up there. Then we do one more test and we got the result 75%. This is up there in this drawing, 75% up there. And people would say, okay, this is a good improvement. It was actually very good. So that change of the setting of the hearing aid was a good idea. But this is a significant difference. And if we really go into all this and look into the mathematics and statistics of it, the answer is that those two results are not significantly different. They are different, okay, but they are not significantly different. The point here needs to fall outside this cigar or whatever we should call it. So in order for a starting point with 60 to have something which is really significantly different, we have to go up here and end up at something which is 85 or something. We have to come outside this shape. So the point must fall outside the shaded area. If you would like to have this a little bit more narrow, you could increase the number of words, going from 25 up to 50, for example, which is very often used in the US instead of only 25 words. That would make it easier, or not easier, but it would make it easier to get a significant difference if you have more words. Or you could say this significant thing here is based on a 95% significance level. If you lose a little bit and say, okay, it would be okay if it's just 90% certain that we have a significant difference, then that would also be more narrow. So this is the way of doing it. This is a little bit surprising, perhaps, that you need that much change in order to be able to say this is a significant difference. Some other things. Everyday sentences, walking around in the kitchen, this is not my task. It's a natural development. The cat came home again. That's just sentences. And when they are used for speech intelligibility measurements, there are some restrictions of such sentences. Very often you would say only 5 words in the sentence. This is typical for the hearing in noise test, HINT, the hearing in noise test, that you have 5 words in the sentence. a limited number of syllables, maximum 4 syllables per word. For example, development, this is the limit. The sentences should have a neutral meaning, no bad words or something like that, no questions, and no names. That's typically the restrictions that you would put up on that. And the result when you're presenting such sentences like these, number of correct understood sentences in the list. That's one way of making the scoring, that you say, okay, if the sentence as such is understood correctly, then we'll make a check mark and say, okay, this was good. But you could also say number of correct understood words in the list. So you have to find out how many of those words in the presented sentence was correct. So that's another way of make the scoring on. And of course, all this will influence on the results. You will get some other percentages if you choose one or the other. There's also something called a matrix sentence test. That's a closed test because the possibility of responses is limited. These sentences, they have the same structure. You start with a name and a verb and a number and an adjective and a noun. And for each of the columns here you have 10 possibilities. Peter, Kathy, Lucy, and so on, that's the name. So some verbs here, sold, ordered, and so on. Number 3, 9, 19, 15, 2, and so on. And adjective and a noun. And what you do is that you could make a combination of these words here. So, for example, a presentation could say, Stephen brought 4 pretty chairs. That's one sentence. And you could make every other combinations of these. So there are a lot of sentences that you can come up with from this way of doing it. And then we would listen for the response from the test subject. And before that, I have to say that the sentences may be unrealistic. When you just combine all these things together, sometimes it will sound crazy. This may not be correct, and that's how it is. But then when we look at the response, then maybe the response was Stephen got 4 pretty rings. And then we can calculate how many words were correct there and so on, and you can continue on that. This is a way that is very efficient in a computer to make it run in a computer, and you could even avoid listening to what the test subject is saying, because you could ask the test subject to pick the word that they think they heard, and then let the computer do all the work, and you can just sit down there and wait until the test subject has finished its test. That's the matrix test. Then some final remarks here. There are many parameters in speech intelligibility testing. That's one of the things that I will emphasize, and that means that it may be difficult to compare measurements from one clinic to another unless they are using the same method and procedure and scoring method and all these things. And then don't forget this significance issue, which may be a little bit surprising. But speech intelligibility testing is more informative than the audiogram for evaluation of communication. The audiogram, is just a test of how much level you need in order to hear a pure tone one at a time. But for speech intelligibility and understanding speech and so on, these measurements are, of course, more relevant, even though they are still some far from the real life situations. Okay, thank you.